Hi guys. Hi Lopa, what are you doing in school, Lopa?
We're kind of reviewing the unit circle and we're like putting it on a graph kind of, and we're starting stuff like that.
Okay, nice. Akash, what are you doing?
We're doing unit circle too.
Okay. Krish, what are you doing in school?
We're also doing the unit circle, and then we started on coterminal angles, and then also sine, cosine, and tangent for the unit circle.
Okay, okay. Okay, so I did this. Let's go ahead. Let me share my screen. I'll go ahead with sinusoidal function graphing. Okay, so let's go ahead with this one. So last week we did the unit circle, right? So we'll start putting it out, putting the graphs for sinusoidal curves. Okay, so let's have this in place. Okay, I really want you guys to know a couple of definitions, okay? So let's see. We'll go ahead and graph the sinusoidal functions. So from our unit circle, right, we have this sine graph. So there are a couple of things that let's consider the sine theta function. So here I really want you to understand a couple of definitions: amplitude, midline, frequency, period. We can understand this, then graphing will become very easy. Okay, now from the unit circle, remember it started with 0, we went like this: pi by 2, pi, 3 pi by 2, 2 pi again, right? So 2 pi was the end. So basically we started at 0, then it went on increasing. At pi by 2 it reached its maximum for the sine graph I'm saying. Then it went to the negative. When did it, so at pi it crossed 0, went to the negative, and then at 2 pi it came to its original position of the 0 axis, meaning the y equal to 0 axis. So here the amplitude, I want you to understand these definitions, right? Period is, it starts at 0 and it again reaches 0. So this is one period. This we have already discussed. So in this case period is 2 pi. What is frequency? Number of cycle the graph repeats in 1 radian. Number of cycle the graph repeats in 1 radian is 1 by 2 pi. Always it is equal to 1 by the period. Okay. And now coming to the amplitude, right? Amplitude is this distance. Amplitude is this distance or the negative of this distance. Let's say coming to the midline. What is this midline? Midline is the middle line. Here y equal to 0 is the midline. These are very raw definitions of whatever I have given. Amplitude is the highest point, literally from the midline. From the midline, what is the highest point? That distance is your amplitude. The period is 2 pi, meaning period is, suppose if you consider this point, right? What is the period? Again when it reaches the same point, right? So till here. So from here till here, when you think about it, it is the same distance 2 pi. This minus this is 2 pi. So I really want you to understand the difference between amplitude, midline, frequency and period. So let's see. I'm going to give you some definitions. Okay, so let's see. Half the difference between max and min values. So consider a sine curve. This is your max value. This is your min value. So basically that is your min. This is your maximum. This is y equal to 0, which is the midline. For the midline, what do? You do min plus max divide by 2. It's just the average of minimum and maximum. It is so useful, guys, in so many cases. Now, what is the period? How are we going to define the period? Period is, or a cycle, right? So basically, let's say this wave starts at this point 0, then whenever it comes back to 0, so basically in a sine wave it's 2 pi. Okay, so period is when the same cycle, see, this cycle comes here and then it repeats itself, right? So that is a period. And then the frequency is the reciprocal of the period. Basically, frequency is the number of cycles the graph completes in 1 radian. Okay, so here period is 1 by frequency. Frequency is defined as the number of cycles per radian. The number of cycles per radian. Number of repeats, number of repeating cycles per radian. Number of cycles, okay, per radian. Any question, guys? So these are the 4 definitions I would want you to know. Can I move on? Okay. Let's go here. Akash, what are you doing in school?
Unit circles.
Oh, unit circles, okay. Okay. Now let's see. I will take a graph. I will take a nice graph. I really want a nice graph. Let's see. I'll take this graph. Okay, I'll have this as my permanent graph. Okay, we are going to go ahead and graph sinusoidal curves. This is easy provided you understand. Okay, this is far more easy than unit circles. Okay, unit circle is a part of it, but it is far more easier than unit circles. Okay, let's see. Okay, so we are going to go ahead and plot 2 cos theta, 2 cos theta, 3 sin theta. Let's see how we are going to plot 2 cos theta, 3 sin theta. So let's say first we'll plot f of x equal to, let me do sin theta first, 3 sin theta. So whenever you see functions, sinusoidal functions of sine and cos, right, we are going to have it in the format, okay? The f of x function, sinusoidal function, can be defined as a cos theta or a sin theta. This is the minimal way of defining a sinusoidal function. There is much more to it. We are not analyzing any of that. We are just drawing simple cos theta, sin theta functions, okay? So here when you think about it, it's a cos theta, a sin theta, okay? I'm not including several of the parameters which are a part of sinusoidal curves for us to make things easy. What is this a? A is the amplitude. So now, generally, if you consider the parent graph, right, sin theta. So how do you draw the graph? Sin theta starts at 0. At pi by 2, it reaches its maximum of, let's say, 1. It reaches 1. At pi, it goes to 0 again. And then 3 pi by 2, it goes to the negative maximum. 2 pi, the cycle is complete. So this was our parent graph. This was our parent graph. So here. Now, with the amplitude of 3, how will you change it? See, all your y values get multiplied by 3. So what happens? If it is multiplied by 3, it still stays at 0. So I am drawing the graph for this one. But again, here 1 is multiplied by 3, right? So the value becomes 3 here. Then again at pi, 0 is multiplied by 0, see, even if you multiply the value of 0, all your y value gets multiplied by 3 because your original was sin theta, now you're multiplying 3 sin theta. So this becomes this. Now again, at this point, it will come to the negative 3. and then it'll go back to 1. Any questions? It's clear, right? Now, let's go ahead and see. See, sine curves, I have not considered any phase shift, anything, meaning we are considering the minimal sinusoidal function sine and cos. Now, let's go ahead and plot 2 cos theta. F of x equal to 2 cos theta. Before we get on to this one, right, I don't know how much you're familiar with sine theta curve goes like this. Cos theta reaches its maximum at 1 and then goes like this, meaning it starts at 1, okay, and then it goes like this. Any questions? Any questions? Both the period is 2 pi. For a parent function, the period is 2 pi. Now, for 2 cos theta, what are we going to do? For this, we really need to understand the unit circle, okay? So, let's say for a sine theta curve, right? Let's say 0, I have to have pi by 2, pi, 3 pi by 2, and then I'll have sine theta, cos theta. Let me draw that in here. You'll have to memorize this. Okay, now for 0, sine 0 is a 0, cos 0 is a 1, sine pi by 2 is a, sine pi by 2 is what, guys? From a unit circle, sine pi by 2 is a, guys, you're all with me?
0.
Sine pi by 2 is a
1.
1.
Oh,
Okay. Now sine pi is the left side, right?
0.
0. Cos pi is
Negative 1.
negative 1. 3 pi by 2 is below,
Negative.
bottom.
Negative.
0 and negative 1, right? So 0 and a negative 1, correct? Then you have 2 pi becomes your 0 values. Does that make sense, guys? So this is how I plot this. I got it from literally the unit circle. Unit circle here it is what? 1 comma 0. This is 0 comma 1. This one is minus 1 comma 0. Unit circle, right? This one is 0 comma minus 1. So this is cos 1 0 minus 1 0. 1 0 minus 1 0. Do you see it? So sine value is 0 1 minus 1 0. 0 1 0 1. What did we do? 0 1. Yeah, 0 1 0 minus 1. So we are correct. Did you guys get it? So this is what from the unit circle I derived this. Okay, this is the basic parent function, sinusoidal curves, just the parent functions. Now, if I add on amplitude to this, right, I'm just adding amplitude. So if I want to graph f of x equal to 2 cos theta, what do? Cos theta, first I'll draw my parent function, okay? 1. At 0, I have a 1. Let's say this is a 1, this is a minus 1. At 0, I have a 1. And then at pi by 2, it goes to a 0. Then pi is a minus 1. And then 2 pi, what happens? It goes to a 1 again, you see. But then 3 pi by 2 is a 0. So I have all my points. I just draw this. So what is a period? It started at its highest point. It has to come to its highest point. So this is one period. Any questions? This is 2 pi. For parent sine or cos curves, the period is 2 pi. Why it is 2 pi? Remember again the unit circle. We started here. We went on pi radians, another pi. So 2 pi. Again the cycle repeated, right? So the period is 2 pi. Any questions? Now you're going to draw, guys, next. Can I move on? Drawing graphs slowly becomes difficult. Can I move on? Okay. Let's see. 3 sin theta is all easy. Now, I want you to tell me what is, okay. How about this? Okay, I really want you to plot min-max value, amplitude and intercepts. Let's see. Let's go to 3 sin theta. I'm going to draw it like this, right? I'm going to draw it like this. 3. 1, 2, 3. 1, 2, 3. Sorry, here. And then you're going to have 0 here. Now guys, what is the amplitude, x-intercepts? Let's do all that, please. So let me try out the min value, max value, amplitude. Let's write out all this. X-intercepts. Can we write out all this? What is the min value? What is the min value, guys?
-3.
-3. Max value?
3.
3. Amplitude?
Well, that's the period length, right?
Amplitude. Amplitude is how high it is.
Oh, 3.
Yep. No, yeah, 3. So when you think about it, amplitude is 3. Okay. Then
0, pi, and 2 pi.
so basically amplitude is what?
Like how tall it is?
Amplitude is how high it is, but usually how do you calculate it was what I wanted to ask you.
From
Amplitude,
the midline.
You just count from the
Yes.
y-axis, the x-axis to the tip.
You count from the midline to the max point.
that is true. Midline to the max point you can calculate. See, midline you can do for calculating the midline. The easiest way is min plus max by 2, right? Yeah, min plus max by 2. It's the average, whereas the amplitude is min or max minus min by 2. You got it? So the difference divided by 2. So basically 3 minus 3 divided by 2. Amplitude is calculated like this. Midline, if you know the min and max, you just find the average of the two. That is your midline. -3 plus 3 divided by 2 is a 0. Coming to the x-intercepts, what are the x-intercepts? There are several x-intercepts. So within a period, you'll have to specify 0, pi, 2 pi. Any questions? Now, what is the period? Period is 2 pi. What is the frequency of this sine curve? 1 by 2 pi. Slowly, we are introducing several definitions. As we move up, it's going to become very complicated. Can I move on? Lopa, are you following, Lopa?
Yeah, I am.
Okay. How about this? How about a cos function? Let's write out the x-intercepts. I didn't do it, right? 2 cos theta. Let's see 2 cos theta. I really wanted to do that. F of x equal to 2 cos theta. Can one of you tell me 2 cos theta, right? So we said it starts 0, it is a 1, right? And after that pi by 2, it becomes a 0. Here it gets to its negative maximum. And then it goes through this, goes to the maximum again. So that covers one period. Meaning when you think about it, it covers one period. Now guys, can you tell me the x-intercepts? It's a little different. X-intercepts occur at pi by 2, 3 pi by 2. Then min and max are min equal to -2.
Miss Priya,
Max, yeah, ma?
you said that the intercepts like where pi over 2 and 3 pi over 2 aren't those y-intercepts?
I'm sorry. They are x-intercepts, ma, because it crosses the x-axis, right?
But x is 0 at pi over 2 and 3 pi over 2.
X
It's
is
like the
I'm
90
sorry,
and
y-intercept.
270,
Okay,
right?
okay. Got it. Okay, wait. They are the zeros, ma. I should have written it as zeros. Yeah, zeros are the x-intercepts, right, ma? They are not the y-intercepts. Why do you think, Dhwani, they are the y-intercepts?
Because like on the unit circle at like 90 degrees and 270 degrees, x is 0 because the coordinate points are 0, 1 and 0, -1.
This is pi by 2. Here, this is 1, 0. Did I make a mistake? Wait, let me see. 1, 0. This is -1, 0. This is 0, 1. This is 0, -1. Okay, so I'm drawing the cos curve. Cos curve means 1, 0. Yeah, 1, 0. And then what? -1 and 0 and -1. 0. 0 is at 180. Wait. Minus 1, 0, correct. So at pi, it will be what? It is a
So
minus 1.
aren't like the x-intercepts at pi and 2 pi, or and 0?
X-intercepts are where?
At pi and 0, or 2 pi, same thing.
You're
Because
talking about the
that's when
sine curve. You're talking about the sine curve or cos curve?
the cos curve.
Okay, let's
Because like that's when you have a value, right? Because
cos, this is sine, correct?
yeah, x is
I
cos,
am
and
talking about
so
the I am talking about the cos curve.
yeah.
1, 0, right?
Uh-huh.
I am talking about the cos curve,
Yeah.
right? 1, 0. So what are the coordinate points? So what are the coordinate points? 0, comma 1 from here. 0, comma 1. Then pi by 2, comma 0. Then pi, comma minus 1. Then 3 pi by 2, comma 0, 2 pi, comma 1. Does that make sense?
Wait, how did you get the coordinate point 3 pi over 2?
3 pi by 2 is here. Cos
No,
is here.
I understand. So how did you make that into a coordinate point? Wouldn't it just be like, because isn't that just the radians and not the coordinate point?
Okay, let me go back to the unit circle. This is the unit circle. Okay, this is 1, comma 0. This one is 0, comma 1. This one is 0, comma minus 1. This one is minus 1, comma 0. Okay, with respect to your angles in radians, right? 0, pi by 2. This is 3 pi by 2. This is, I'm sorry.
No, that's pi. That's just pi.
1 second. Pi, 3 pi by 2, 2 pi. What I'm saying is this represents your cos theta, this represents your sine 0, this represents your cos 0. This represents your cos pi by 2, this represents your sine pi by 2. This represents your cos pi, this represents your sine pi. This represents your cos 3 pi by 2, this represents your sine 3 pi by 2. Any questions there?
No.
Now can I tabulate it? If I tabulate it, what happens? Let me put it as a table, meaning 0, pi by 2, pi, 3 pi by 2. It's enough, okay? So cos, sine. What are the values? 1. I'm going to start with 1, 0, minus 1, 1, 0, minus 1, and 0. Sine, these values 0, 1, 0, minus 1. Make sense?
Yeah.
Now, if I draw the cos, I was drawing for cos curve, 2 cos theta, right? So let's not worry about the 2. Cos theta, if I want to draw the curve, right, it starts with a 1. Okay, 1. This is a minus 1. Okay, and then at pi by 2, it goes to a 0. So that is an x-intercept, correct, ma? It crosses the x-axis. Intercept is cutting across the x-axis, correct?
Yeah.
And then what? Pi is a minus 1, 3 pi by 2. 3 pi by 2 is a 0, 2 pi is again a 1. Did that answer your question, Dhwani?
Yeah, because like it just look, you use like different axes, so it makes sense now.
Yeah, so basically what we are doing, we are plotting xy coordinates only. Okay, but then where you're getting confused, I can understand. Okay, the 0, pi by 2, pi, 3 pi by 2, that gets you on the x-axis. Okay, the actual values, these are the y values of the graph for cos. These are the x values of the graph for sine. These are the y values of the graph for sine. Make sense? The x values are always the angles. Did that make sense?
Yeah.
Krish, are you following?
Yeah.
Manav, you're following?
Yeah. Yeah.
The angle that we go, right? Here it was pi by 4, 1 pi by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4, 5 pi by 4, 6 pi by 4, 7 pi by 4, and 8 pi by 4, right? So that is your x-axis. Similarly, 30 degree, 60 degree, what was that? Pi by 6, pi by 3, then you had 1 pi by 3, 2 pi by 3, 3 pi by 3, 4 pi by 3, 5, like that you had, right? That is always on your x-axis. But for simplicity's sake, we don't map all the angles. Instead, we only do, here we are very, what to say? We are very extravagant. We have put pi by 4, pi by 2. Each interval is a pi by 4. Okay, so pi by 2, pi is easier for us. Pi by 2, pi, 3 pi by 2. Only this one, this one, this one, this one. We put it on the x-axis. Now the actual value of cos of that angle, we mark it and plot it. That becomes your f of theta. F of theta, for cos theta, the curve is this. Make sense? Manav, you're following, right?
Yeah.
Okay. Now suppose, let's say if I have minus 2 cos theta, what would happen, guys? Minus 2 cos theta. When you talk about the unit circle, again I can go with the unit circle, show what will be the difference. Again I can show transformation as well. Let's say we have theta, we have angle, we have the x value is your angle, right? And then the y value is your cos of the angle. Okay, this is your parent function. Okay, I'm going to have transform function here. Okay, now angle, I start with 0, pi by 2 minus pi by 2 pi, sorry, 3 pi by 2, 2 pi. I'm going to have these angles. Okay, from your unit circle, you already know, I'm not thinking about a transform function. Okay, so cos 0 at this point is 1, then it's a 0 at this point. Here it is a minus 1. Here again, what happens to it? It is a x value is 0, and then 2 pi, it becomes a 1. However, the transform function here, it was multiplied by a minus 2. So all your y values get multiplied by a minus 2. So when I write out for the transform function, it becomes this. Right? How do I plot it? Now 0 has a minus 2. Because of this minus, right? Let's see. First let me plot the parent function. If I want to plot the parent function, so here it is 1, here it was a minus 1, right? I'm plotting just the parent function, okay? 0 was 1, pi by 2 was a 0, pi was a minus 1, and then 3 pi by 2 is a 0, 2 pi is a 1. This is my parent function, remember? So this is my parent function. One cycle is enough, right? But this is not what I want. What I want is 0. I'm going to put it in a different color. Now, I want the transform function. 0 has a negative 2. 0 has a negative 2. And then pi by 2 is a 0. Pi is a positive 2. See, when you multiply by minus 2, this one I'm multiplying by minus 2, it becomes a plus 2. Okay, so it becomes a plus 2. It goes here. And then 0, again 0, and then it comes to a negative 2. So when I plot my original function is this. This is my transformed function, which is different from my parent function that I wanted to graph. But you don't have to go through this process every single time. It's so confusing. You know what I do? I will draw my parent function, see what is the transformation in here. The transformation is reflection on the x-axis, and then the amplitude is multiplied by 2. That means 1 always becomes 2, but there is a negation. It is reflected. So whatever this point was will come here, but then it was multiplied by 2, so it came here. 0 will remain as 0. Similarly, for the parent function, whatever was negated, see, this was a negative, what was that? This was a negative 1, right? This was a negative 1. Actually, this is a negative 1, okay? This was a negative 1, right? Negative 1 goes across the x-axis here, but then the amplitude was 2, so it gets multiplied by 2, so it goes here. Make sense, guys? If you have any doubts, you have to ask. Dhwani, are you following?
Yeah.
How about the others? Akash, are you following?
Yeah.
Shragvi, you?
Yeah, I get it.
Okay, now Akash, have you started doing this in school?
No, we didn't. We only started doing it with the circle. We didn't do it with the graph plane, but we did like all the sine cost values.
So
We
are you
did,
following?
yeah.
So from the unit circle, this one came up. From the unit circle, literally
No.
you can write these values. After that,
Yeah.
you have to transform them and put it
No,
into a
they just last time they just taught us the unit circle in like sine 60, 30, 45, like that.
that is very useful as we move on. Okay, but slowly you will come to graphing, then we'll go to transformations. Okay, here the transformations are all very simple, but the highest complex transformation can add everything. It can have a reflection, it can go on the left, right, up, down, all that can happen on the cost curve, sine curve. But if you're not following, please stop doing. Excuse me. How about this? You're going to try this one. I don't want to do easy graphs, but I don't know, guys, whether it's easy or hard for you. I want to do a harder graph. Okay, minus 4 cos x. Minus 4 cos x. You want to do it by yourself and show on the video, or how do you want to do, guys? Would you be able to graph this? First, draw the cos curve. One main thing that you have to by heart is sine curve goes like this. Cos curve, ordinary parent function, goes like this. Okay, the period is 2 pi. The period here is 2 pi till here. So it starts with a 0, goes to a 2 pi. It starts up at 1, goes up to a 1 at 2 pi. That you need to understand. This is cos theta, this is sin theta. Sin theta, cos theta always starts up. Sin theta always starts at 0. Cos theta always starts at 1. This is your parent curve. Now, based on this, you can perform any transformation. When there is a minus, it's a reflection on the x-axis. This multiplication by 4 is your y value is getting multiplied by minus 4. Can you draw and show me, or do you want me to do? You have to let me know. Shragvi, did you follow?
Yeah.
Okay, then can I expect you to draw and show me the graph for minus 4 cos theta?
Yes.
I can wait, guys, but if you're not getting, please message me. I will do it on the board again. I would be happy to do it, but if you understood, go ahead and do.
Miss Priya, could you do it on the board?
Yeah,
Like,
absolutely.
the period stuff and the like the 4, like the like the -4. But I just don't really know how to. I just don't like
No
that.
problem. I'll do it on the board. Okay. So, do you want me to put the table and then show you again?
No, the table's not necessary.
Okay. So basically, how will your cost curve be? Meaning, if I were you plotting it, right, I cannot do it just like that. I'm also starting new to study this cos theta, sin theta. Cos theta, I know. Let this be 1 and minus 1 for easy sake, okay? So cos theta starts at 1 and at 2 pi it has to come again. So in between the two, right, what is that? In between the two, it has to again come up. So here,
Isn't the interval like -4?
sorry ma'am, sorry. The interval is not -4, ma. See,
I mean, like the amplitude, right?
amplitude is -4. No, I am plotting the original parent cost curve.
Oh,
For
okay.
you all to understand well and not make mistakes at all, I'm just plotting the original cost curve. Got it?
Oh, okay, yeah, I see.
Always I do, always, for however, wherever we go, I plot the parent curve first. Then only we can, relative to that only, it's very easy to perform the transformation. So basically, because of the minus, whatever graph, wherever it is, it gets reflected on the x-axis. If this was here, my graph, original graph that I want to draw for this function, the point comes here. This cannot get reflected, so stays the same. This one, if it got reflected on the x, yeah.
Is this correct? I think I understand. Like, I drew it wrong.
Exactly. But did you move the amplitude to 4?
Yeah, I did. You
Reflection
can
on?
see that on my edges that it says -4 on the bottom.
Exactly correct. Now you have to increase the amplitude. Amplitude became 4. It's not 1 cos theta as a parent function. You see, amplitude was 4 means this is 4 and this is 4. Here, instead of -1, it will come to a 4. This is my point. This is my point. here, it should go here. Then it will come to a 0. 0 becomes 0, and then this one again shifts up. So what happened? This one cannot shift up, right? It has to be reflected. If it is reflected, it has to come here, but then amplitude multiplication gets you here. So what happened? It started here, goes up, goes like this, comes down. The cycle, see, from here. Did we do it correctly? Did you guys get it? Manav, did you follow?
Yeah, I got the same shape. I got the same graph.
What I just want to make sure we are doing it right. Hold on. 4 cos x, right? 4 cos x, I want to start minimum and then come back to minimum. Correct. Start minimum, come back to minimum at 2 pi. See, the thing is, after this, the cycle repeats. Again, it is at minimum, goes up and comes down again. So you don't need to know, you don't need to show the second cycle. Any questions? Shri, did you get it?
Yeah, I'm getting it.
Okay, how about Shragvi and Lopa? Can you show me your graphs? Because if we don't understand this, there's no point moving ahead as well. Parvini, did you get it?
Yeah.
Can I move on?
Mm-hmm.
Okay, Lopa and Shragvi, I sincerely don't understand if you're getting it or not.
I get it. I just didn't finish graphing it, but I wrote the table down.
Okay, great. Okay, now let me ask you. A sinusoidal graph has been vertically shifted. Let me put it down. I'm going to have the same graph here, okay? Sinusoidal graph, it's a tricky question, was vertically shifted. That means what? Vertically shifted, the max point was at 100, minimum point was at 20. Max point was at 100, minimum point was at 20. Can you please tell me what is the midline and what is the other one? What is the midline and the amplitude? What is the midline and the amplitude? That's the question. What is the midline? What is the amplitude? Please, you come up with your thoughts. I'll help you here. Our usual cos curve starts here. The maximum is 1. The minimum is -1. You know what to draw. Midline means middle line. It's very easy. Amplitude is the distance to the max from the midline. Do you want to try? Or the distance from minimum to the midline. It's not a hard one. If you have been following, you should be able to get what is the midline and amplitude. You want to try? Or you want me to try? Akash, you got it?
Yeah.
Wait, I'm sending you the midline and amplitude.
Yes. Oh, you got it?
Yeah. Oh, like that. Remember that like problem that you taught me last week that I asked from school? It's
Yes.
exactly like that. So.
Yes, that also helps. See, basic understanding, if you understood that, everything is easy. Advik, you're following Advik?
Yeah.
Okay. Parvini, okay. Oh, that's right. Nice. Manav, nice.
Miss Priya.
Akash, nice. Yes, I saw your message, Parvini. You have to go.
Okay, thank you.
Have fun.
Thank you.
Bye.
Bye.
Dhvani correct. Krish correct. Shri, did you get it? Shragvi, Lopa, I need your answers, guys. You have to let me know.
Wait,
One
Miss
second,
Priya.
Auntie.
Wait, Miss Priya.
Yeah.
Well, my answer is correct.
Yes, your answer is correct. See, the basic conceptual understanding will get everything correct. You don't have to doubt yourself. Correct. Lopa. So here, max is 100. Let's say 100 is here. Okay. 20 is here. With this graph itself, I'm plotting. Okay. 20 is here. Max happened here. Minimum happened here. So what is in between for the midline? What can I do for the midline? So basically, to add both, divide by 2. 100 plus 20 by 2. That's the average is the midline, right? So midline happens at y equal to 60. And then amplitude is this distance, right? That's 40. Any questions, guys? Shragvi, did you get it?
Yeah.
Okay. Now, there's one more question your way in the same lot, but then after that we move on. Okay. After that we move on to accommodate transformations. Okay. How about this? How about this? Can I erase this graph maybe? I don't want to erase because that's my... Okay, how about this? Maximum value is 135, minimum value is 90. Where is the midline and what is the amplitude? You can send it to me, guys. Now I am going to introduce transformation on sinusoidal graphs.
Midline and amplitude?
Midline and amplitude, yes. Remember, midline is the average of max and min. Amplitude is the difference between max and min divided by 2. Midline is added value of max and min divided by 2. Did you guys get it? Yep. Guys, you all got it very quicker. Okay, Shri. But next week I would expect you to answer, Shri.
Yeah.
Okay. Yeah, that's right. Krish, Advik, did you get it? Shragvi, I would like to get your answers, ma.
I'm send. I
You're
sent.
sending? Okay. Even if you did not understand, I have to know. Okay. Now I'm going to introduce one thing. The factor B. Okay. Let's see. I'm going to make up my own equations for transformation. So, did you get it, Shragvi? Lopa?
It's not letting me send my answer.
Can we watch something?
Yeah. Midline and amplitude, did you get it, ma?
We don't have Disney Plus or Netflix.
One is the difference, one is the average, right? Shragvi, did you get it?
Yeah.
I'm just waiting for you and Lopa, so you have to let me know.
But it's not letting me send my answer. Like I have.
What is it, Shragvi?
It's saying that I can't chat with meeting group chat during this meeting. Like it's not letting me send it.
Okay. Shragvi, I can chat with you, Shragvi. How about this? Can you reply to the message? Lopa, did you get it? Yeah, I think everybody got it right. 112.5 and 22.5. Can I move on? Shragvi, did you get the values?
Yeah, I got that.
Okay. Now, A cos theta, A cos B theta plus D. Let's introduce that. A cos B theta plus D. You see? You remember, guys, in our cubic functions, quadratic functions, what did we do? We had some standard equations, right? These are the standard equation. This is the standard equation for cos function. This is the standard equation for sine function. Okay, here D becomes your midline. A becomes your amplitude. Okay. Now, what is this B? If you think about it, all the while, for a common cos theta function, f of theta equal to cos theta, we did not consider any transformation, just like a parent function. Remember our y equal to x square, we did it like that, right? Then what did we learn? We brought in so many things. We brought in either the 2 can be with x, meaning we brought in a factor. Remember, it can be a or b. We brought in a x square equal to y. So a was multiplied to the y values, remember? Otherwise, it can also be y equal to 1 by b x the whole square. Remember, if it was inside, it was a transformation. It was a stretch or a compression on the x horizontal axis. If it was outside, it was a transformation, or it was a stretch or a compression on the y axis. It is what we studied. Same concept applies here. Okay, we will bring in, see, on the theta, basically the sine graph. Let's say our parent sine graph was this. Because of the b, it gets thinner or it gets thicker, meaning it gets wider. Make sense? So that b value, basically b value gets multiplied by the theta. So what happens? Sometimes the period will change. Because of this, the period will change. So how it is going to change? 2 pi by b is going to be your period. For any curve, 2 pi by b is going to be your period. Or b can be found out. If you want to write the equation, b can be found out by dividing 2 pi by the period. If you can take it in, then slowly we can digest the transformation easily. Here, this is the amplitude. This one, right, just like what we studied with the parabola y equal to x square, you either did 2x square or you did y equal to 1 by 2x the whole square. So this is your b value. Do you see it? A value is this. And then you also pushed it up or pushed it down. Remember, plus 4. This was your D. Am I making sense, guys? Okay. Okay, good. Now, we are going to accommodate to all of these transformation in our graphs. First, what we'll do, we will be given an equation, you're going to graph it. Next, what we'll do, you'll be given the graph, you're going to find the equations. Can I delete this? But remember, guys, b value is 2 pi by the period, or b value can be 2 pi by period, or period can be 2 pi by b. Can I move on? Okay. Now, let's go ahead. Let me give you these. I'm going to plot minus 3 sine 2x. Minus 3 sine 2x. You want to do or you want me to do, you have to be very clear with. I'm going to have a graph. Nice graph. Okay. I want a full graph as well. Let me see, guys. Hold on. This one is a full graph which I can use for plotting. Okay. I'm going to use this. So let's go ahead and plot minus 3 sine 2x. Minus 3 sine 2x. I will plot it, guys. Minus 3 sine 2x. Okay, guys. Given this function, this is a transformed sinusoidal function, right? So the parent graph, you all know, I'm going to, again, as I said, right, I'll always plot the parent graph. Okay, I'm not comfortable not doing it. So I will always plot the parent graph. So that way you know where the parent graph lies and what transformation you did. This is not the graph that we want, so I'm putting it as a dotted line. Okay, now I'm going to draw my or a transform function given. Here you have, first of all, let me write out the amplitude. What is the amplitude here? What is the amplitude? What is the midline, guys? What is the period? What is B value? A value is the amplitude. What is the amplitude here? Krish, are
1.
you getting bored? Go ahead.
1. On the parent graph, it's 1.
Parent graph is 1 ma here in our graph.
Oh, there, 3.
3 amplitude. Midline?
What, on the transformed one?
On the transformed one. Yes, everything is on the transformed one now. See, plus D is your midline. D is always the midline. Remember, our transformed equation becomes A cos B theta plus D. So this is our f of theta. This is the transform graph. This represents amplitude. This represents 2 pi by 2 pi by period. This represents midline. So what is the midline?
So it's like pi by 2, 3 pi by 2.
Midline is 0 plus 0, right?
Yeah, 0.
Now, what is the B value in here? Do you see here? B value is clearly a 2, B theta, right? So now, what will be the period? Period is 2 pi by B. So period of the graph becomes 2 pi by 2, which is a pi. So period of the graph, period of my transformed graph itself is pi. So whatever graph I draw, the cycle ends at pi, and between pi to 2 pi there will be a second cycle. So basically the zeros should occur at 0, pi by 2 and pi. And what is the maximum? What is the maximum? Maximum is 3, but it has got a reflection. Do you see? Maximum is 3. So basically I should have plotted like this. Maximum is a 3. So this point should have moved up. And then what? Maximum is a 3. I'm sorry. Amplitude is a 3, right? So if we want just 3 sine, right? The period is as well pi. Because of the 2, the period changed to pi. Okay, whatever cycle I want goes from 0 to pi. That we need to understand first. Now, 3 was the amplitude, means it should have gone here. Do you see? It should have gone here. And this should have been my point. This should have been my point. However, here there are too many things happening. What? The period became pi. So within this period itself, you have to see the graph going up, down again. So 3 zeros came here. 1, 2, 3. So this was 3. This should have been a 3 here, like this, right? But it can't go like that because of the negative sign, right? It can't go like that. What happened due to the negative sign? The negative sign got this reflected on the x-axis, right? So it became here to a -3 and then go to pi by 2, and then between pi by 2 and pi by pi, right? This is your middle, right? So this came here and then came down. So the final graph is here, here. Did you guys get it? You can erase all of this. You don't need the parent graph. You don't need any of those. Did you guys get it? So how do we verify this? Let's see. See, first of all, the amplitude is 3 and the period is pi. Within the pi, you should start here and should end at 0. That has to come. So this is your middle. In the middle, again you have to come to 0. Right? Yeah, in the middle you have to come to 0. So what happens, guys? You go down, meaning earlier the sine graph was up down, right? So it has to go down up because of the negative sign. Any questions here? Any questions here? Guys, any questions? Okay. Do you think you can draw the graph for you can draw the graph for, let's say, I want to give you a simpler one. Minus 2 cos x by 2. 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 Do you want to try or you want me to try? I'm okay with anything, but please let me know. What do you want to do? Guys, please let me know, guys. Please start writing. What is your amplitude? What is your amplitude? What is your B value? What is your period? Then what can I write? Frequency. All this, if you start writing, it becomes easy. Do you want me to write it?
Can the amplitude be negative?
Amplitude is, let's say, amplitude is
Oh,
2.
that's a reflection. Sorry, my bad.
Negative just means, yeah, it's a reflection of the x-axis. Meaning opposite points you'll be plotting. We'll remember that, okay? 2, and then B is what, here?
The 2 pi over. Oh wait, sorry, that's the period. That B is just the period, right?
B. No. Oh, yeah.
Or is that 2 pi over the period?
B, okay, the general formula is f of theta equal to a cos b theta.
Yeah.
So what is B here?
Oh wait.
B is this.
The x over 2?
1 over 2. Don't worry about the independent value. 1 over 2. Now, period is 2 pi by b, right, guys? So, what is the period here?
Pi?
Is it pi? Think about it, guys. It's
Wait.
fraction division, right?
Oh, 4 pi.
Horizontally stretching the graph, yes. You are horizontally stretching the graph. So the period increases, right?
Yeah. To find the period, it's just 2 pi over b, right? Okay. And b is always after
Yeah,
like
I have written on the
Wait,
right.
and Miss Priya,
Are you
the
able to see
period?
what I wrote on the right side?
And what do you mean by like frequency? Like the amount of times it can fit on the like what amount of times it occurs?
Dhwani, I did not get your answer. I'll come to you, Manu. What is that, Dhwani?
How did you get the frequency again? I just wanted to write the
Oh,
formula.
frequency is 1 by period.
Okay. Okay, I see.
Manu, what is your question?
Oh, I was just gonna ask the 1 by period thing.
Okay. See, one thing what I want to tell you is this you're multiplying it with your x value, correct?
Yeah.
This tells you whether you are if you multiply your x-axis by what are you doing? So the factor here is 2, right? So you're basically stretching the graph. See, when you multiply things with the x value, x horizontal compression or stretch, you remember, even in a parabola, whatever was in the denominator was your factor.
Okay.
So the same logic applies here. You don't need to change anything in transformations that you have studied. So here the period is going to be 4 pi.
And could you like give us one more example of this
Yeah,
problem?
I will draw. Yeah, we will do more, and I will draw the graph too. I don't have the graph for this one. Okay, let me draw the graph. Okay, so the period is 4 pi. Now, amplitude is 2, cos, right? This is cos. So, amplitude is 2, there is no negation, right? Amplitude is 2, okay. Period is 4 pi, okay. See, the thing is, I can't show. Okay. So 2 cos x by 2, so the period became 4 pi, so it will extend, right? let me see whether I can search for a graph that is 4 pi, so that way you will be better in understanding. Or I can go to GeoGebra or Desmos graphing calculator. Okay, if you have doubts, right, when you're working in school, right, let me show you guys. Give me a minute. What was the question I gave you? 2 cos x by 2, right? Yeah, that's a good one. Okay, I'm done. So now finish this. So now let's go back. I'll show you in a Desmos calculator as well. Okay. So basically this goes at a 2, meaning at 0 it was a 1, right? Because of the multiplication by 2 it goes there. The period is 4 pi, guys, meaning the period is 4 pi. Usually the period is 2 pi. So our ordinary graph, what does it do? It comes like this, right? Let me show you. Cos pi by 2 is a 0, then pi is a negative 1. Negative 1 means it comes here and then it goes here, and then for the 2 pi it goes like this, right? This is our original graph, right? But now it got stretched. When you think about it, 0 to 4 pi it will go. Just because it goes to 0 to 4 pi, your middle ground is 2 pi. Middle ground was pi, that's when you had the lowest minimum. So you will have your lower minimum here. In your transformed graph, you will have your lower minimum here. And at pi, you will have, so what is the halfway between 0 and 2 pi? Pi. So there it will cross 0. So your transformed graph, right, will be stretched a lot. It goes like this and then goes like this, and at 4 pi it reaches up on top. Any questions on this? Any questions on this? Did you guys understand? Huh?
Yeah.
Yep. So this here, where is this 2? 2 is way down right here. Any questions you have? Ma, this should be 2, ma, again.
No
This should
questions.
be 2. Yeah, this should be 2. This should be 2, ma. So basically it should come here and then move here. Got it? So here as well it has to come here, and then 2 pi it has to touch the lower half. 2 pi it has to, pi it will cross 0 point, and then again this is not right when you think about it. Pi it will cross 0. It is stretched a lot, okay? So it has to touch the lower point only here. You see? So starting from here, it comes to the same point here. Do you see the lower point? That is 4 pi. Any questions, guys? Okay. Now let's move. Let's see 1 or 2 more for sure. How about okay. Now things are going to get complicated, guys. Let's try. 2 sine x by 2 plus 1. 2 sine x by 2 plus 1. 2 sine x by 2 plus 1. I'm going to have this graph. 2 sine x by 2 plus 1. Wait, I think this graph is good. 2 sine x by 2 plus 1 equal to f of x. Can we try? Do you want to try or you want me to try? I'll start writing the amplitude. What is the amplitude here? 2. What is the midline?
1.
1, correct. So let's draw the midline first. If ever we have the midline, I would really want to draw the midline. Okay, that sets me the tone for the graph. Y equal to 1 is my midline. Amplitude is 2 means it is a sine graph. No reflections. So automatically sine graph starts at 0. This is your 0 here. See, your midline is your starting point, right? But before I say all that, right, I need to write out all the parameters. What is your B value?
1/2.
1/2.
1/2, because B theta, right? B theta, 1/2. Now, what is the period?
4 pi.
Yep, 4 pi. Okay, now let me take this 2 pi to 2, minus 2 pi to 2 pi, so that I don't want to extend to the right side, okay? What else I can write? Frequency is 1 by 4 pi, okay? Then anything else we want to write? D value is 1, which is the midline. What else I can write? That's all, that's enough. Okay, but let's plot the graph. At midline, it's going to be 0, okay? Now, the graph is going to be stretched, okay? So basically, how am I going to do this? 2 is going to be my maximum, right? Any thoughts you want me to do? I can go ahead and do as well, guys. So basically, let's see. It has to, where is it? Okay, we start at 0. Then at 2 pi, oh my god. At 2 pi, it has to come to a 0 again. Let me draw the graph. Here 0. So at 2 pi, again it comes to the normal 0. Now, what is in between? Pi. This is where it has to attain its maximum, which is a value of 2. But I need to plot the entire thing, right? Here I got it, okay? Now it is going to go down. Similarly, I can't go down this side. It's very hard to show. So let me go down this way, but then till what? Meaning 2 is the maximum, means what is the minimum, guys? Minimum we did not write. What is the minimum? Maximum was 2. What is the minimum?
0.
0.
Good. 0.
For
Yeah.
the visual
Oh,
graph or transformed?
Always transform.
-2?
It can't be a negative. Minimum value I'm asking. Midline is 1. Because of the midline change, everything changes. Remember?
It's 0 now.
Oh, it's 0. Oh, yeah. Wait. It's not 0, right? 2 is here.
Because originally it's -1, now it's up 1.
Yeah. Okay. But did we do it correctly? Then this is wrong, guys. Amplitude is 2 means it has to go up, right? What is the max value? We did not write that. That's why we got confused. So midline is 1 means what is the max value? Amplitude is 2. Midline is 1. So what is the max value?
Oh, 3?
3. Max value is 3. It has to reach a 3. What is the down minimum value?
-1?
-1. Good job. So that happens at here. Now at pi, it again goes to 0. Now let me connect these points. Does that make sense?
So the upward and downward curve makes up one period, right?
Yes. See, if you consider starting at this point, it has to come to the same point, Amma. After
Okay.
both the cycle, yeah. After the one entire cycle. Can we move on? Can I go ahead? So, whenever you have a midline, right, the important aspect is first write your minimum and maximum. As I said, right, min plus max by 2. One is min plus max by 2. One is min minus max by 2. So, basically, min plus max by 2 is your midline. Okay. Min minus max by 2. The difference divided by 2 will give you your amplitude. When you think about it here, see, max minus min. That is what is correct, right? Max minus min. So here when you think about it, it gives you the amplitude. Max 3 minus minus 1 by 2. So it's 4 by 2. 2 is your amplitude. Midline is min plus max divided by 2. 3 minus 1 is 2. 2 by 2 is 1. So midline is 1. Any questions, guys? Can I move on? Okay, we'll do 2 or 3 more problems with the transformations, guys. It's quite slowly it becomes hard. 3 minus 4 cos 2x. Wow. 3 minus 4 cos 2x. I'll do it on the board if you want to, but you can contribute too. 3 minus 4 cos 2x. How do we do this? See, guys, this one I really want in my standard format. A cos bx plus d, right? Please let me rewrite it as minus 4 cos 2x plus 3. This is the best way. Now, please let's go ahead, start writing our parameters. What is the first parameter I can write? Midline, max, min, period, A, B, D, frequency. What is, first of all, let me write out A. A is a 4. A factor is minus 4, okay. B is what? Amplitude, I'll write it separately. Amplitude is clearly a 4, okay. B factor is a 2. D factor is a 3. Now tell me what is the, I don't want the period now. What is the midline? What is the midline? Guys, D is the midline, guys. What is the midline?
3.
Yeah, y equal to 3 is the midline. Midline is an equation. Y is equal to D. I can't use this graph. Okay, max is what?
7.
Max is, see, from 3, you have to add the 4. 7. Good job. Now, minimum?
0, 4 down. For max, it's 7.
Minimum is where, ma?
Minimum is -1, but for max, you wrote down 4, 1 at 7.
Sorry, 7, ma, 7. Period is what? For period, what do we need to find? B. B is a 2. 2 pi by B. So period is what? Pi. Any questions, guys? Any questions still here? Guys, these are important, okay? Once you understand one, school will be so easy. Did you get this? Can we go ahead? Okay. Okay, I'm going to change my graph. I can't use this graph, or I'm going to change the way it is written. Let's see. Okay, so there is a negation as well, and it has to go to pi. Let's see. How about this? I'm going to change these, whatever is written here, okay? 3, 6, 9. 3, 6, 9. Okay, can we try this one? Let's try this one. How do we want to do? So first I want to draw the midline. Midline is at a 3. We'll do only 0 to pi, or
Wait, is it
pi
3 minus 4 cos?
Yeah, ma, it is 3 minus 4 cos 2x. I rewrote it as minus 4 cos 2x plus 3 for me to have the standard format. So I drew the midline. I'm done with that. And then this is a cos curve. Cos curve means my maximum occurs at 0. My maximum is a 7. 6, 8. So my maximum is a 7. Okay. My max is a 7. Okay. Then pi by 2, it's usually a 0, correct? But you know what? But pi by 2 can't be a 0 here. Why? Because my period itself is a pi, right? Period itself is a pi. 0 to pi by 2, what is halfway in between? You have to see pi by 4. So that becomes a 0. Now, then where is its minimum? Meaning pi by 2, right? It reaches its minimum, right? And then halfway between pi and pi by 2, again it reaches 0. Then at pi, it reaches the same point again, because pi is your period, right? Why I am plotting 6, this is 8, right? So in between is the 7. That is why I have it here. the lowest is, this is a 2, right? So let me change this minimum to a -1 exactly. -1 is somewhere here. Does that make sense? But what did we forget? I cannot draw the graph yet. What did we forget? We forgot something. We forgot a very important thing. What is it?
Original graph?
No. Original graph, no. You don't need to draw the original graph at some point. But we forgot something. This is not my points. When I connect this, I will not get my graph. Why? What is that I forgot? Cos attains its maximum. This is the parent graph, I can say. But this is not my transform graph. Why? Something feels wrong. What is it? There is a minus, right?
Yeah.
So all these points get reflected, right? This one becomes your maximum. So what happens here? It goes like this, the graph. You got it, guys? The black hard ones is the right graph. Does it make sense? Pi by 2 attains its maximum. And then for pi, you see, it reaches the 0 point. Does that make sense? This is the graph. It's enough if you show from this point to this point. Any questions? So the graphing becomes slightly difficult unless you, if you understand only, it becomes easy. Now what we have covered only a cos bx plus d, right? We have covered this, we have covered this, we have covered this. What we have not covered, a cos, we have not considered the phase shift, b times x plus c plus d. That is going to come in next week. C is your phase shift, meaning the entire graph can be moved by pi, left or the right, meaning translation, moving the entire graph to the right or the left is pending with this C. That we have not learnt at all. So slowly next week we only introduced, first we introduced a cos theta. That was a slight difference of a. Now we introduced a cos bx plus d. Next week we'll introduce a cos b x plus c plus d. So C, which is the phase shift, comes in. Once we finish all this, we can go ahead and do word problems. Any questions, guys?
No.
Okay, I'll stop here though. Okay, but we can see you again next week. We will be slow, I think, but we will get it done. If you have any questions, ask. Otherwise, we'll see you next week.
Bye, Miss Priya.
Bye.
Bye. Advik,
Bye.
are you solving Advik for you?
Yeah, I
Bye, Miss
understood.
Priya.
Yeah, I understood all the
Thank you.
graphing and everything today.
Good. Bye-bye.
Yeah.
Bye, Miss Priya. Thank you.
Bye.